Come back to Further Solutions Academy. Further Solutions Academy. Encourage us more. Help us to share our video and also subscribe. If you have not subscribed before, help us to press on your subscribe button. And if you want to contribute to this platform, buy board and camera and also other things, join us on this number 34. You can call us, you can WhatsApp us, and also your Telegram is allowed. Anyone you want to, you can reach us on that to buy, just to make a contribution. We're always there for you. Now, okay, we have a problem to work on, which is called equilibrium forces. Equilibrium forces are I think we have started forces, which is we have done coplanar forces, which is a resolution of two or several forces, component of forces, and this time around we are just working on this part, which you can now say that okay, before we continue, let me quickly explain what we understand by equilibrium of forces. Let me explain something. Now, for a force, for body to be equilibrium, it must not have tendency to rotate, does not have tendency of what? Rotate. Now, if does not rotate or there's no any movement taking place on it, it means it's possible it has the tendency of what? To be equilibrium. And you know what this force is? When somebody is sitting down here and that person is sitting down, I have to come with instructional materials. I'm sorry for that. Now, there is 2 points. This. If they are balanced, it means it's equilibrium. But if one is not coming, one is going down, and that is, they are not equal. That's what I'm trying to say. Now, when I have it, the equilibrium is maintained if the total sum of forces acting on the body is zero. That is what is. Please take note of this information because we're going to be working on it. Now, that is what I'm working on. Now, I want to let us to understand that that is what equilibrium is talking about. Now, 3 forces in equilibrium. That is what I want to work on in this video. 3 forces in equilibrium rather. Now, 3 forces in equilibrium. Now, 3 forces in equilibrium. If I have it, the indirect use of sine rule will play a role here. It is known as Lami's theorem. Lami's theorem. Now, Lami's theorem lets us to know that when you are having 3 forces acting on a point, I think let me quickly draw this thing so that you can be able to see it. Now, this is Lami's theorem. I have force A, force B, force 3. Now, let me call it T1, let me call it T1, T2, T3. Now, that is what Lami's theorem is talking about. Now, it means I'll be having, let me call this one beta, let me call this one theta, and let me call this one alpha. They are all forces. Let me give a direction to it. Direction is very important, which is to let us to know that we are talking about what. That is what. Now, with this, we will understand what is called Lami's theorem. Lami's theorem let us to know that let me state it. Lami's theorem. Okay, how do I use my statement there? I'm not an Englishman. I have to be very careful. Now, when we talk about Lami's theorem, if three forces acting at a point are in equilibrium, then each forces is proportional to the sine of the angles, to the sine of the angle between the Lami's, between the line of action of the other two forces. Please take a look at that in statement. I won't be able to write it down. That is what Lami's theorem is saying. If three forces acting on a point are in equilibrium, then each forces is proportional to the sine of the angle between the lines of action of the other two forces. Now, that is what is Lami's theorem, which let us to know, we all know what is called sine rule. Sine rule is what I'm trying to say there. My T1, and it will be having sine T alpha equals to T2 sine theta equals to T3 and sine beta. That is Lami's theorem. It means this is coming to this is coming to this is coming to that. What I'm trying to do that, and what I stated there. If you can get the statement very well, that is what we talk about on Lami's theorem. Now, since I have the Lami's theorem, let me quickly show one or two examples. That I don't need to speak much English anyway. Now, let me try to explain question that will help us. Okay, now a particle x of weight 60 kg. Please take note, I will explain something here. 60, because we're talking about weight. I will try to explain something there. At rest is suspended two light stream x and z, xy and xz, which angle of 45 degree and 75 degree respectively with the horizontal find the tension in each stream correct to 2 decimal places. Now, this is the question I'm trying to explain. With this, you will understand it better. Now, the first thing I will notice is my x. Very important. I'm already on solution. Now, the first thing I will notice on x, we're talking about xy and zx. And the weight will act down, which is my weight will be 65 kg. Now this is mass. This is a mass. Now my weight, it always equals to mass times gravity, which is equals to 65 multiplied by 10, which is now equals to 650 Newton. Please take note of that. That's what I was explaining then. Now, weight and force, they are of the same Newton, but the only thing that is there is that once we are talking about weight, you must explain it with the respect of what? Gravitational force, which is gravity. Gravity is acting on it. You know what is gravitational force. I think we'll talk about it later. Now, we are talking about xy and xz. Xy and xz. It means I can call one z, come this way, their force, and also another one, which is y. Very important. Now, I think I'm interpreting. Now, anytime you have word problem to do, learn to interpret the way the question comes. Don't just cram and pour. Now, the next thing is that we are talking about a spring light on the clinical plane. Which angle of what? 45 degrees. Now, I will now to horizontal. Let me generate my horizontal plane. That is my horizontal. We know that this is my horizontal. Horizontal. Please note that. Now, first one is 45 degrees, which is 45 degree, and the next one is 75, respectively, which is here will be 75 degree. Now, this is on a straight line, which is angle on a straight line is equals to 180. When you add up this, minus it from 180, it will surely give us something. It will not give us something, which it will give us 60 degree, because it will give us 120. Yes, to give us 120, which is 60 degree. 60 degrees, sorry. Now, with this, I can continue by having, let me redraw it with what I'm having here. It means since I have it this way, and with the help of my Lami's theorem, everything I need is already available. These are tension, they are forces. Now, I'm looking for the tensions. Now, what should I do next? I can return this to this, which I have it, and I have my weight this way. Now, this one will be weight, will be x, and will be z, will be y. Take note of that. Now, what I'm just doing here is that I will add it. This is 90. This is 90. When I add it up, and I will add it up, I will get 650 degree and also 135 degree. That is very correct. Now, here will be 60. We have done that earlier, which is 60 degree. Now, everything I need is now available. Everything I need is now available. Now, my weight is already given, which is what? I have, which is equals to what? 650 Newton. 650 Newton. With this, I can continue my work, which by having my sine rule, which is a Lami's theorem, let us know this sine 60 equals to what next? I have x, y all over what? Sine 165 equals to xz all over what? Sine 135. Now, with this, I'm good to go. With this, I am good to go. Now, I'm looking for what? The spring. Find the what? Tension. I'm looking for a tension. I can now generate any of the tension. With this, we should be able to solve it and end it. Sorry, should I assume? Okay, let me do one of them for you anyway, for you to understand. Now, xy all over sine 165 equals to, what is my weight? My weight is 650 divided by sine 60. Now, my sine 60, I will now move on by xy equals to 60 multiplied by sine 165 divided by sine 60. Now, which I'll be having, I'm trying to use calculator, please, calculator. Now with my calculator, I can now say that, now with calculator, I will be having 168.23 divided by sine 60. Let me use 0.8660. By so doing that, I will have all I need, which is I'll be having 195.26 Newton. That is two decimal places. Now you can do the second one and generate whatever you need, and that is all. Okay. Let me show one more example on this part, and before we okay. Now another question comes this way. 30 degree, and don't want 3 kilogram, which is my mass, my R. This is a tension. My tension. Now, in the diagram, an object of mass 3 kg and hanging from a light extensible string is pulled put aside by a horizontal force R. If the spring is inclined at 30 degrees to the vertical, and the system is in equilibrium. Calculate in Newton. Calculate in Newton. The tension T in the spring. 2, the force R. Take G, which is gravity, at 10 meters per second squared. Now, that's what I have for you at this point. Let's try to after this I will try to explain another one and move on to the next solution to this problem. Don't forget that the first thing I work on, this is not usable. I can't use it now because we are talking about mass, and it must be in weight. it must be in weight. This is 30. This is not 30. Now it must be in weight, which I will turn it to what? How do I turn it? My W equals, which is my weight, equals to mg, which is 3 multiplied by 10, which is equals to 30. Now, which I have it that way. I cannot continue with this. I have to resolve this. I have to redraw this. Now, how do I redraw it? I will have it as my tension, which is my 30 degree. And in our bearing, I've explained to you that we have what is called corresponding angle. If this is 30, it means here will also be 30. Now, it means that will be also be 30, and down we call it what do you call it? Weight, which is 30 Newton, which is my weight. Now, it means 30 plus this plus 90, it will be 120 degree. 120 degree. Now, since I have it that way, and here will be 90, here will be 90 degree, and here will be that'll be 250. Yes, because 60 will be here. That'll be 150 degree. By so doing that, I can solve whatever I need, which I will continue with my Lami's theorem. W all over sine 120 equals to T all over, this is my tension, let me call it T all over sine 90 equals to, and also my R, this is my R, which is my R, it will be all over what? Sine 150 degree. Now, by so doing that, my tension, which is the first one, T, I'm looking for tension, which is first, my T, which is question number 1. I'm looking for tension. It means my tension will be T all over sine 90 equals to, what is my weight? My weight is 30 Newton all over sine 120. Now, which I'll be having my T equals to sine 90 is always 1. We all know that as 30 divided by what? 120. Sine 120, second quadrant, which is sine is positive. It means it will be positive, which I'll be having 30 divided by sine 120, it will be 0.8660. Now my T will be equals to what? My T will be equals to 38. Is it 38? Calculator. Calculator. Now 34.664 Newton. That is my tension. Now the second one, I'm looking for my my first R, which is my R. I'm looking for my R. Now my R from here, I don't need to stress myself. I can say that what? W all over sine 90 equals to, all over sine 120 equals to my R all over sine 150 degree. Now, which I'll be having 30 divided by sine 120 equals to my R all divided by what? Sine 150. Now, which I'll be having my R equals to 30 multiplied by sine 150 divided by sine 120. Now, which I'll be having 15, because of this is going to be half. Yes, all over divided by 0.8660, which is my R, will be equals to 17.32 Newton. That is all. That is all about that. Now, that is all about that. Okay, I will stop here for now, which I will give 2 or more examples in our next video so that you understand the 3 forces equilibrium. Okay, before we discontinue the movement, I mean, we have to understand that this is Further Solutions Academy. I encourage us more, help us to share and also subscribe. Subscribe to this channel if you are not. To reach us, to contribute to this platform, you can call us on this number 23. Now, with this number, you can call us, you can WhatsApp us, and you can Telegram also is allowed. Telegram is allowed. Once again, thanks for watching.